First, we require the HTTP module, which is a built-in module in Node.js used to create HTTP servers and clients. Next, we set up the server using the createServer method. This method takes a callback function that is executed each time an incoming request is received. Here, we're creating a server instance. The callback function takes two arguments, rec and res, which represent the request and response objects, respectively. Inside the callback, we begin by logging to the console. This message indicates that an incoming request event has been received and handled by the event loop. Next, we use the writeHead method on the response object to send an HTTP status code of 200, indicating success. We also set the content type header to text, plain, to inform the client that we're sending plain text. Then, we end the response process by sending the text "Hello World" followed by a new line character. The end method also signals to the server that all of the response headers and body have been sent. With this, we close the callback function. Our server is now set up to respond to incoming requests with "Hello World." The server needs to be bound to a port to start listening for incoming connections. Here, we're asking it to listen on port 3000 and the loopback address 127.0.0.1. Once the server starts listening, we log to the console that the server is running and on which port. This message confirms that our server setup is complete. We finish this with a closing parenthesis and a semicolon, which closes the listen method call. Now let's demonstrate the event loop in action. Using setInterval, we're scheduling a function to log event loop tick to the console every 1000 milliseconds, or 1 second. This showcases the event loop's ability to handle periodic tasks without blocking. Running this code will start the server, and you'll see event. Server is running on port 3000 logged to the console. Then, every second, event loop tick will be logged, demonstrating that the Node.js event loop is continually running and able to handle both server requests and scheduled tasks concurrently.